Hi, I'm Phil, and today we're going to look at a new series of projects using the Fischertechnik Kits. And I'll also be interfacing my projects with the microbit using the Kitronik Interface Board. So following me using this mind map, and I'll describe what my goals are. I'll talk about some of the Fischertechnik kits and the interface board, and I'll review my first project, which is a ventilator fan, and I'll follow up with some references, and stay tuned because after that I'll give you a demonstration of the first project. Well, here are some of the Fischertechnik kits that I'll be using. And the microbit will be a controller which is integrated with the models that I make from these kits. So the Fischertechnik kits that I'm using, most of the models will come from the Universe 3 model, but that will be combined with the motor set, particularly the XS motors, and I'll be using some components from the electronics and the sound and lights kits. So the applications are in STEM education, but this is a chance to actually look at some mechanical engineering, and we'll be combining the coding with electronics and mechanical components. So some of those include things like gears, pulleys, motors, and they'll be combined with sensors like thermistors, and we won't be just looking at coding, we'll be looking at the combination of all of these. But my other aim is the way that the models are presented, and it gives an opportunity for STEM students to demonstrate and show and tell their models, which are in quite a presentable and pleasant way. But it's also for hobbyists that are interested in learning through making. So an important component here is the Kitronik Interface Board. And you can see the microbit on the left here, and it plugs into the interface board on the bottom. And you can make models like the model next to it. So all of this depends on the existing interface and power to Fischertechnik kits. And most of those use a 9-volt battery system. And the interface board that comes along uses plated holes, and you can use the standard Fischertechnik plugs that you're used to using on the existing models. So here is a closer look at the interface board, and on the bottom left you can see P0 and P1, and these go directly to the microbit ports 0 and 1. Next to that, there are switches A and B, and they connect directly to button A and B of microbit. And on the top right, you can see the connections for the motors M1 and M2. So you can control those two motors either in the clockwise or the anti-clockwise direction. And there is plenty of software available, either using the Makecode or the MicroPython libraries that are available. And these are all supplied by Kitronik. So before I get into the project, I had to explore a little bit more detail about the electrical interface, because nothing is published, not even the output voltages. And I discovered that while the motors go up to 9 volts, the output voltage on ports 0 and 1 are still at the microbit level of 3.3 volts. And my first project is a fan control, where I use a thermistor, which measures the room temperature, and it's connected to the microbit computer. And if I want the fan on, I press button A, and it then allows a thermistor to control the fan. But I also want to demonstrate the use of buttons A and B, because they're extended from the microbit. And I want to switch on the LED if I press button B. So the main objective is to see if the interface board actually works. So do some commissioning testing. And not only the hardware, I also want to look at the Makecode extension blocks to see if they work. And I'm going to introduce two state variables, one for the motor and one for the Fischertechnik LED. And I'll be constantly reading the temperature value from the Fischertechnik thermistor. So I'm using all components from the Fischertechnik Electronics Board, and we'll see if it all works together with the microbit. So the thermistor is measuring arbitrary units. It's not calibrated in degrees centigrade, but for, say, a room temperature of 24 degrees, I'm getting a reading of 95. And if it gets up to 98, which is the threshold value, I switch on the fan, as long as button A has been pressed and the state variable is positive. For the hardware, I'm using a microbit. In this case, I'm using version 2, but it will also work with version 1. I'm using the Kitronik Microbit Interface Board, together with the Universe 3 Fischertechnik modules and the XS motor and gearbox and thermistor, also from Fischertechnik. And for the software, I'll be using the Makecode extensions. And you can see on the right that I've got controls for the motors, and I can turn on the LED on or off, or read the two sensors, the phototransistor and the thermistor. And here's a simple program. So it starts up on the top left and initializes the variables, including the temperature threshold at 98. And in the forever loop, it's polling the thermistor value. And it shows that value on the microbit LED array. And if the button A state is on and the threshold has been reached, it will turn on the motor. And the advantage of using the event programs, that is pressing either button A or B, means that you get an immediate effect. So if you want the LED to go on, you don't have to wait until it goes through the polling routine in the main forever loop. You can get an immediate reaction and turn on the LED if you press button B. So here are my references, and this is only the start of a number of projects based on Fischertechnik, microbit, and the Kitronik Interface Board. So stay tuned and I'll give you a demonstration of the board itself. Hi, I'm Phil, and for this demonstration I constructed the Fischertechnik's ventilating fan. And you can see the Fischertechnik's construction here with the fan and the vertical column It has a pulley, and it normally is operated with a manual handle. What I've added in two stages extra components. The first one is a small electric motor with a gear chain, and that comes from Fischertechnik, and it's connected via a shaft to the motor, to the mains drive. And in addition, I've also connected a drive for the motor, and it's a Kitronik interface for microbit and the Fischertechnik components. So the microbit computer is on top, and on the bottom here is the Kitronik Interface Board. And at the moment, it's connected to A and B buttons. So I've replicated button A over here. So if I press button A, it's the same as pressing button A on the microbit computer. In addition, there are two sensors, or there's one sensor, a thermistor or a temperature sensor, and it's connected to pin 0. The other port could either be a sensor, but in this case I've got it as an actuator, and the output voltage goes to this small Fischertechnik LED. And again, if I activate button B, which is replicating button B over here, it will turn on the LED. So if I do that, press button B, the LED will go on. Just goes on and off. The temperature that I'm now measuring is displayed on the microbit LED array. So it's in arbitrary units, and at the moment it's currently showing 92. But if I put my fingers on the thermistor, notice how the temperature is rising. So it's 97 at the moment, and 98. And you'll notice it's now acting as a thermostat, and the fan is now on because it's above the threshold. And if I remove my, you'll notice that the temperature, I moved my hand, and the temperature is now going down, and it's below the threshold at the moment. So here's the ventilating fan, one of the Fischertechnik projects in the kit called Universal 3, and it's been expanded using an electric motor, but also an interface to the microbit computer.